Hi, and here we go again with another video on integration. So this is the second part of the video on areas under a curve. And in the last section we dealt with the basics. Let's have a look now at kind of an area under a curve. And this is under a power 4 curve between the x-axis and the lines x equals 3 and x equals 1. So let's dive straight in. So there's the definite integral that's going to do this calculation for us. Integrate between 3 and 1. So let's do the integrating. Plug in the values, so we've got to put in the upper limit and do the subtraction with the lower limit. And we end up with some fairly nasty looking fractions, but I'm not going to worry too much about those, I can deal with them. And we end up with an area of minus 128 over 5. At which point, hopefully, you're looking at that going, well, hang on a second, how the heck can we have a negative area? Area is not negative, that makes absolutely no sense at all. So why is this happening? What's going on? Well, let's have a little look at the sketch and see if that'll answer our question. And hopefully straight away, there's the sketch. Hopefully already you can begin to see why it's happening. As it turns out, the section of the curve that we're looking at between 3 and 1 is below the x-axis. So we're looking at this blue area here. And if you remember from the previous video, we said that this area comes from a result of doing lots of tiny little thin strips of rectangles where the height of each rectangle is the y-coordinate. And because the area is below the x-axis, the y values, the heights, are negative. So that tells us that the areas are all negatives as well. So we're summing up a whole bunch of kind of technically negative areas. Now, we know that kind of saying that the area of something is negative doesn't make a lot of sense. So all we've got to do is say, well, the value of the definite integral is negative. So when we put, if we evaluated this, it's quite all right to say the numerical value of this integral is minus 128 over 5, but in the context of the area under the curve, this blue area here itself, we just say, okay, it's got an area of 120 over 5 units squared, so we can kind of just essentially just drop the minus sign. So there is a subtle distinction between what the numerical value of this integral is and how it relates to the area in the context when we're applying it to this curve here. Okay, now, this idea of the fact that the y values, these kind of the heights of the rectangles being negative, does create a little bit of an issue that we need to be a bit careful about. So let's have a look at this curve here, and I've sketched it to begin with, and we want the area of the blue bits. So it might be, you can look at that, you can think, okay, well, what is the value of the definite integral going to be? Because we're looking for that definite integral, the area of the curve between 5 and 1, and that will give us our blue bits. And so let's just work it through, and as I say, you've probably guessed what's going to happen. Let's just see it in action. So there's the integral. Plug in the values, so chucking 5 into our upper limit, there's our lower limit. Do some working out. So the first bracket here gives us a value of minus 25 over 4, and when we evaluate what we get when we plug in the 1 in, we get minus 25 over 4, and again you can see what's happening here. We've got minus and a minus is a plus, so as it turns out the value of that integral, the definite integral here between 5 and 1 is actually 0, because essentially what's happening is these two areas are cancelling out against each other. Now, one thing that we just need to be a little bit clear on is we've got this value here, which is minus 25 over 4, which you might think is that bit, and this value here, minus 25 over 4, but you might be looking at it going, well, hang on, that can't be that because that's above the x-axis, but what you need to remember is that the minus 25 over 4 is everything from 5 all the way back, including this stuff, all the way back to 0, so including this bit here. And this bit here, the minus 25 over 4, again, that's all of this, including that bit there. So it's not just a case of that area there is minus 25 over 4, that area is plus 25 over 4. It includes the integral all the way back to 0, and that's because our subtraction includes everything from 5 to 0, everything from 3 to 0. Right, long story short, we've got a value for our integral up here, which is 0, but we want to find the area enclosed by the curve and the x-axis, so we still haven't actually answered the question. We need to know what is the total of these areas. So what we're going to have to do is we're going to have to split this calculation into 2. So we're going to have to figure out what's the actual value of that bit there, which is between 5 and 3, and then also what's the value of this bit over here, which is the integral between 3 and 1. So if we can work these two things out separately and then put them together at the end, then we're going to get our total blue area. And for this bit now, we've kind of already done all the integrating up here, so I'm just going to cut straight to it and say, well, that one gives us an area. So this blue bit here has got an area of -4. And as it turns out, this one here has got an area of +4 between 3 and 1. So in actual fact, our total blue area here is going to be 8 square units. Right, moving on. As we've seen previously, when you're dealing with areas under curve, it's always a good idea, wherever possible, to sketch the curve. Or you might find in a lot of cases in exam questions, if you've got to deal with it, chances are they'll have the sketch there for you. But it's just a good idea to have a little look and think about what's going on. So let's have a look. We've got an example here. We've got a quadratic curve, x squared minus 3x, between these 2 points. So straight away, there you go. There's our sketch of our curve in between 4 and 2. So we can see we've got one positive and one negative area. And I've already done the work to say, well, kind of when that point there, the point of intersection, we can get it from here. Putting this equals 0 gives us a point of intersection of 3. So we need to evaluate between 4 and 3. Let's get that done, which is 11/6. Evaluate between 3 and 2. Let's get that bit done. There is, I know I'm kind of rushing fairly swift through those, but let's say if you want to spend the time just to look a little bit more carefully about where I'm getting these numbers from, then let's say you just know you just got to pause the video. And we get that. And again, when I'm doing these, I'm always thinking, well, you know what, I know this is going to be a positive area, so I'll make sure if that is positive, that's okay. I'll make sure that this thing turns out to be a negative. If that not turned out to be a negative, I'm thinking, okay, something's not quite right. So it's just little checks along the way. And so the total area is those two bits put together. And so we've got an area of 3 square units.